All right, so what about this one? Well, this one, I think I'm going to solve for that x. So I'm going to take the 2y over, so I'll get x equals a positive 0.2y plus 1. Then I'm going to take this piece and plug it in here. And so negative 10 times 0.2y plus 1 plus 2y equals 5. Now I distribute. So that's going to be 10 times 0.2, so that's going to give me a negative 2y minus 10 plus 2y equals 5. Well, those cancel, and I get a negative 10 equals 5. Well, that's false, and so there's no solution. And no solution, remember, it's inconsistent. And that's all we have to put is it's inconsistent and then no solution, whether it's you write the empty set or no solution. Okay. All right, what about this one? Well, I think I might go with the top one because unless I solve this one for x, if I solve it for y, I'm going to have fractions. If I divide either one of those by 6, it's going to work. So let's solve the top one for y. So negative 6x plus 6y equals negative 12. So we'll add 6x. 6y equals 6x minus 12. Divide everything by 6. So y equals, now we have x minus 2. Now I can take that and plug it into here. And if I do that, I have 8x minus 3 times x minus 2 equals 16. Don't forget to distribute, carry the negative, so we have 8x minus 3x, and then plus 6 equals 16. So we'll subtract 6. 8 minus 3 is 5x equals, and that's going to give me 10. Divide by 5, x is equal to 2. Okay. So if x is equal to 2, we plug back into the original equation, and we get negative 6 times 2 plus 6y equals negative 12. So that's going to be a negative 12, so I'm going to have to add 12 to both sides. So 6y equals 0, so y equals 0. So I'm saying my solution is 2 comma 0. Now we have to check it to see. So negative 6 times 2 plus 6 times 0 equals negative 12. Well, that's 0, so we have negative 12 equals negative 12. That works in the first one. How about the second one? 8 times 2 minus 3 times 0 equals 16. Well, that's 0, so 8 times 2 is 16 equals 16. I don't know why I put another number 1 there. I think my 6 just kind of got funky. And so that works for the second one. So this is a consistent and it's independent. All right, and so that would be our solution to that one. Okay. All right, what about this one? Well, looking at this, I see that second one has a y. And so I'm going to solve for that y. So what am I going to do? I'm going to add 2x to both sides, and I get y equals 2x plus 7. So now I can take and substitute this up into the top equation for y. And so that gives me minus 5x minus 5 times 2x plus 7 equals negative 20. And so negative 5x minus 10x minus 35 equals minus 20. Well, those two combine, so I'll add 35. So that's going to be negative 15x equals, that looks like a positive 15. So negative 15 divided on both sides, we get x equals negative 1. All right, so, and again, we can plug it back into either equation. So if we plug it into the second one, minus 2 times minus 1 plus y equals 7. Well, that's a positive 2, so I have to subtract 2 from both sides, and y equals a 5. So I'm saying my equation solution is negative 1, 5. Now checking it, minus 5 times negative 1 minus 5 times a 5 equals negative 20. Well, that's going to be 5 minus 25 equals negative 20. Well, we subtract that. That's a negative 20 equals negative 20. So it works in the first one. And a negative 2 times negative 1 plus 5 equals 7. Well, that's 2 plus 5 equals 7. So 7 equals 7. So it works there as well. And so it's a independent and it's consistent. Okay. And then that would be my solution. All right. All right, let's pause there.